Hello, everyone. My name is Mühleisen. Many years ago, together with Mark, who is here. Oh, where's Mark? There's Mark. We started a project called DuckDB. Now, of course, it's more than 2 people, and some of them are here. Yeah, it's my pleasure today to talk about DuckDB in the wild. Something that we didn't really expect would ever happen, that we get to talk about DuckDB in the wild, right? So it's actually quite a pleasure for me to talk about how people are doing crazy things with DuckDB and what that kind of means in general for data infrastructure. But first of all, very briefly about what is DuckDB, and I don't have my presenter notes, so this is like completely ad-lib now. And you might imagine that I don't have to sort of look up the notes for this one, but DuckDB is an in-process analytical database management system, and it's made to be simple, easy, fast, and so on and so forth. I'm going to go briefly over why we think DuckDB is important and highlight some of the things that I want to show you. We had some time to think about this, but what fundamentally DuckDB is about is to make people stop worrying about data. Okay, because in the past it was, and I personally have experienced this many times. Whenever you had to look at a new data set, it would start by you being sort of terrified, right? What dark shadows might lurk in these zip files of CSV files or whatever, right? What sort of horrifying encoding choices were made like 20 years ago by the statistics agency in British Columbia, like you don't even want to know. And we kind of set out to change that to data confidence. And kind of the means by which we try to do that is by providing a piece of software, which is DuckDB, to kind of make it more intuitive to work with data, to kind of give you the confidence that no matter what horrifying collection of files will be in front of you, that you will be able to do something meaningful with it, and that you will be able to explore and get some insight, overview, whatever, quickly, without sort of this, oh my God, I have to go to Spark, or I have to suddenly configure CSV reader options, or I have to deal with, I don't know, various encoding issues or things like that. And I've shown this slide before, so maybe you've seen it, but what this comes down to in terms of engineering is that for DuckDB, we kind of have to consider the entire user experience when dealing with data, right? And this is a kind of a departure from traditional work on data management engines, where it was kind of tradition to focus on very sort of meaty engine parts, like the 47th join algorithm, which is kind of funny because we just wrote a paper on joins, but I'm not without contradictions. Anyways, DuckDB is really about the full end-to-end user experience, and that starts from installation, setup, ingestion, running queries, finishing queries, and then taking the result and doing something meaningful with it without sort of having sort of any, how do you call this, friction on the way. So that's, that's like the design principle of DuckDB, to look at the end-to-end user experience. And one way how we achieve a good user experience is by being in process. And that sometimes it's a bit of a technical term. Sometimes that takes some explanation. What does in process mean? Well, it means that the data engine runs within the process that you're currently interacting with. So if you're currently interacting with Python, then DuckDB will run in Python happily. If you're currently interacting with R, then DuckDB will run in R. If you're currently interacting with DuckDB in a browser, DuckDB will run in that browser. So that's really a way that a deployment model, if you want, that we have sort of found is much easier for sort of this whole setup and maintenance sort of problem, and it also has this added advantage that getting data in and out from within this process where your data typically sits is much faster, because we don't have to go through like serialization and blah, 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 blah. So that's in process. Another aspect of DuckDB is that it is batteries included. We really work hard to put a lot of features into DuckDB that normally you wouldn't really expect from a in-process fairly small system, right? For example, we have a very, very broad support of the SQL language. We have readers for tons of data formats. We have exporting tool for a lot of data formats. There's integrations in a bunch of languages. There is, stable storage. There's transactions. All of these things, things that you would normally expect from, let's say, a bigger data management systems are included in DuckDB in a small package, in a sort of convenient sort of way, because we don't want you to basically run, out of energy. So this is why the batteries are included. And it's fast. This is a bit of a relative term, and it's a bit funny because every single data system vendor out there will tell you their system is fast. But I found this tweet that captures this. Somebody said DuckDB is probably the most magical piece of technology in recent years, and that was said in the context of speed. And of course, as you know, every sufficiently advanced technology is indistinguishable from magic. And so I can just say that DuckDB contains a state-of-the-art query execution engine that came out of our past lives or as academic researchers on data management systems. So we had some idea. Best part of DuckDB, it's free, so you don't have to pay. It's just open source software under the MIT license. When we started building DuckDB, we were public servants here in the Netherlands. And we kind of making it freely available is a sort of a way for us to give back to you, the taxpayer. It's true. DuckDB has had pretty staggering growth. This is just an inevitable star, a sort of GitHub star sort of history. It became a bit ridiculous at some point when the growth, approached sort of infinity here. But thankfully, this has sort of fixed itself. One number that I always find totally crazy is the number of unique visitors on our website. So we have a website, duckdb.org. You may have seen it. And as of today, there's 1.3 million unique visitors on this website each month. And we accidentally made one of the bigger websites of the Netherlands. It's bigger than the Lidl, okay? Accidentally. I mean, obviously it's not fair because, the whole world goes to our website and the Lidl is blah, blah, blah. But I thought it was, as a reference point, it was kind of interesting. And then, going a bit towards what we kind of observe at DuckDB, because when we started with DuckDB, we kind of were in this camp. We wanted to make something that worked really well for interactive analysis, where you, the analyst, are sitting in front of your computer and you want to, deal with large data sets, confidently. And then you're in like R, Python, kind of data science kind of use cases. And we see those a lot. Yeah, that's definitely what people do. But we have been surprised a bit by what people are actually ending up doing with DuckDB. So one of the interesting things we've seen is DuckDB as a pipeline component, where, for example, you have like some service that does something with data, some ETL maybe, some sort of general transformation, maybe processing some user input, whatever, that uses DuckDB somewhere as kind of a box in the sort of architectural diagram, right? And I will show some examples of architectural diagrams in a bit. So that was kind of interesting to see that as a kind of totally sort of, would call it headless DuckDB, which is kind of used just in a pipeline without persistence, with ephemeral schema and all of that. And then in the third sort of use case that we've seen is this creative architecture aspect where people put DuckDB in, just about anything. So, if it could be a browser, it could be, a satellite in space. These are things that have really surprised us in terms of architectural choices. Okay, so now I want to, pull out the architectural diagram. So this is the, your sort of horrifyingly standard two-tier architecture, right? You've all seen it in school. You've probably seen it at work. It's boring as hell. You have a database server somewhere, usually represented with this wonderful stack of tables here, stack of, what is that? Disks, I'm sorry. I've seen this so many times, I totally forgot what it is. That's kind of how ingrained it is. And then you have a bunch of clients talking to this database server. Okay, so far, so boring. And then sometimes, because we are, and as computer people, we love to stack things. We say, okay, well, the client's talking to the database server. It's maybe not the best idea. We'll put a bunch of application servers in the middle, and they do some business logic nonsense. And now the clients, they're talking to the application servers, and the application servers, they get their information from the database server. Good. This has some obvious problems. That you've probably run into yourself. Like, these are typically multiple computers, right? Like, you have It's not going to be one computer, this is going to be many computers, and now you have 2 clusters of computers that have to scale separately, and nobody will tell you how to do that. Great. And in sort of analytics use cases, what we often see is that actually that database is not just one database, but it's kind of your warehouse, as they like to call it, of data, where you have a bunch of operational databases here, you know, your Postgres or your, I don't know, don't say the word of evil other companies, have that system here, and that's kind of feeding into your data warehouse, and that's going, and then the data warehouse is sort of serving requests from the application servers, and again, that goes to the clients. Great. Obviously, recently we have sort of killed that architecture and replaced it with something much worse. Instead of the data warehouse, I like that laugh. Instead of the warehouse, we have the data swamp, okay? And then we have something called Apache Spark to kind of deal with the swamp, okay? Here in the Netherlands, we have experience with dealing with swamps, right? It's like you drain them, but that's not what they do. They make it worse. So anyways, you have the data lake, and then the rest is kind of the same. You still have your operational databases going into the swamp, and then the swamp is serving like something on the application server and that going on. Okay, so far so good. Now, let's add DuckDB to this picture. What are things that we have seen in the wild that people do with sort of the classical data architecture? So the first thing that I want to talk about is putting a little DuckDB here on the path between your operational database servers and your data lake. I'm gonna not, stop insulting it. Why would you do that? Well, there's actually very good use cases for this because DuckDB, as I mentioned, has seen a lot of use already in this kind of data pipeline component, and we have seen people use DuckDB to basically batch up, for example, the contents of the changes maybe from these operational databases to actually, for example, already write a Parquet file to the data lake directly without having to go through, yet another zoo of what's it called, Kafka machines, right? And so here is a picture from a talk at DuckCon this year, where Subhash from Fivetran was describing the architecture to use DuckDB as a component in their sort of infrastructure that they use to take information or the rows, the content from the operational databases that Fivetran will convert to other things for you, and use that to rewrite them into Parquet files that then are used in their Iceberg export. So that's kind of an interesting use case there. Next, maybe we can do something slightly more interesting than the Spark cluster. So the Spark, what we have seen people doing is basically put DuckDB in Lambda files for their data transformations, right? In Lambda functions, I'm sorry. So here what we have is instead of maybe the Spark cluster, we have a set of Lambda functions to do our data transformations. And since DuckDB can be installed in a Lambda and be instantiated very cheaply within milliseconds in these Lambda environments, it actually lends itself very well to these transformations because you can basically spin up a Lambda, trigger a Lambda because you added a new file to the data lake, run some transformation with DuckDB, write it back to data lake, and then this goes on, and you could even have a cascade of these things going on. And we've seen this. There is this talk also. Recent talk on, since I don't have the notes, von Okta. Yeah, I can read his logo on the thing, sorry. This talk from Okta, where they describe their architecture, where they basically have this Lambda architecture that basically reads and writes from S3 to do data transformations from what they call the Wild West of input on the left here to the output that eventually ends up in Snowflake. So that's super interesting as well. And they even use a Lambda and a little Duck logo. Next, you could put DuckDB on your application server. And this sounds a bit weird, right? Why would you do that? Because why would you put an analytical data management engine into an application server? Well, there is some good use cases here because the application server is something that you have to already scale to deal with your request load. If you put a data transformation engine into the application server request handling logic, you can kind of naturally scale your application server workload with the data transformation load that it generates. So it kind of, you get away from this double scaling problem, and you can much more sort of creatively react on user requests. Let's say you can allow the user more freedom in what questions they want to ask, because you don't have to create load on the separate data warehouse with your users' questions, but instead you kind of burn the cycles for that directly in the application server, and that's something that you know how to scale, right? So that's something we've seen. Again, I think I have a screenshot here. Yeah, so this is a, yeah, I mean, this is one of these plots, right? It's almost comical, right? So this is before, after, with DuckDB. Nice. And so basically, this is a Reddit post where somebody said, we migrated our Node.js app from SQLite to DuckDB, and the performance gains are insane. And the 97% reduction. Yeah, so that was kind of funny, and that's exactly the use case that I was talking about here. And we can go further, and that's maybe some of the most interesting things we've seen in the recent years, is where people put DuckDB on the client, right? So as you maybe know, DuckDB is fairly small. It's fairly small binary. You can put it in desktop applications, and people do. I think Electron apps are one of the bigger deployment targets for the Node.js client at the moment. You can also put DuckDB in the browser with WebAssembly. In case you're not aware, there is a complete in-browser version of DuckDB with WebAssembly that runs in the that runs on, like, for example, on our website in the shell.duckdb.org sort of demo thing is just WebAssembly, DuckDB running in the browser. And you can do super interesting things with things like dashboards and mobile apps with DuckDB. Like, you can, for example, imagine your fitness tracker app not having to upload the data to the cloud, but instead just doing the analytics directly locally on the device, maybe even with spatial processing, who knows. And here is that's what I mentioned, that's our shell, that's just running in your browser or in your phone, even runs on, I've tried it on an iPhone SE first generation, and it worked, to my big surprise. Here's a talk from another DuckCon that I have forgotten what it was, which company it was from, but what? TigerEye, thank you. They were running DuckDB in their mobile apps that were based on a Flutter framework, I think. Thank you, Gabor, from TigerEye. And here is something from Hugging Face that I thought was hilarious, where they basically put this button that on the website where you can get a SQL console on every single data set they have on their website in the browser right there, powered by DuckDB. So if you go on Hugging Face right now, not right now, I just forgot where the button was. I think that screenshot didn't have it yet. But essentially, yeah, there's this button now that you can just directly go to get this SQL shell. And here is my first attempt of having a video in a presentation to showcase this. This is an example from a DuckDB user where they basically show how they re-render this statistical sort of plot live as you sort of move the slide around within the browser at sort of video game frame rate, and that's something that I personally find very exciting. So that's kind of the new world. And it's kind of funny because it means that if you imagine what the previous world looked like, where you had like this stack of sort of disks here, it now means that the data engine can be anywhere. And I think this is like the new sort of exciting territory, is where else can we put a data engine, and what can we possibly achieve with that, right? I think the sort of the field is still wide open to sort of come up with new exciting deployments, because yeah, we are kind of just leaving the world where we had to always go back to the Teradata or whatever, right? I just briefly want to do a shout out to MotherDucker, giving a talk later, who are doing super interesting things with sort of hybrid processing, where they run queries both on clients and servers. If you're interested in that, probably you will hear something about that from Till, not sure? Yes, very good. Okay, so I think that's kind of it. So I just wanted to stress that with DuckDB we can liberate data processing. We can really just put the data engines wherever we want. And you don't have to rely on decentralized engines anymore. And I just want to have one more slide, actually, So in case you like DuckDB and you need help with DuckDB, we DuckDB Labs, sort of the company that employs most of the DuckDB contributors, we do offer commercial support contracts. So if you're interested in that, get in touch with me. So basically that will give you privileged access to the DuckDB core team. You can talk to me, you can talk to Mark if you want to. You get higher priority issues, which means, we have a special issue tracker for you. You have a guaranteed response time with private data sets, and generally it's possible to get more scope for support. So if you need support for the most obscure API that we have out there, that is definitely possible. So that's it. Thanks all, and happy to talk to you more and everything. Thank you.
Well,
Adam? Okay.
Yep.
Okay.
Could you hear me?
Yes.
Yeah, perfect. Thank you. I have a small question regarding pipelines. You mentioned the DuckDB support pipeline now.
Yeah.
I've tried to Google, and there is no documentation. Could you?
There's no documentation. That cannot happen. We have 1.3 million visitors each month now.
Yes. So, and the first link, it's to the mother duck. Could you elaborate about the pipeline mechanism a bit? So, for instance, if I would like to achieve something like CDC, right? How can I connect to my production database?
Right. That's a great question. One of the things that we do, we have connectors to some popular transactional databases out there. For example, MySQL and Postgres, we have existing connectors to. That's probably going to expand in the future. So that means that DuckDB can basically access tables that are stored in Postgres and MySQL directly. That you could, for example, use to retrieve the recent changes and for your change data capture. So that's there's maybe we should. That your question is, of course, very valid. Maybe we should have a blog post at some point that outlines a bit how these use cases commonly look like, because at the moment, I don't think we have anything written down specifically. Yeah.
Thank you.
Cool. Other questions? Back there. Just have to hand the microphone. Yeah, let's do that. That's excellent.
Hi, thanks for the great presentation. Not too long ago, I tried DuckDB and I was doing some ad hoc analysis on some Avro files that were lying in Google Cloud Storage. So what I figured that DuckDB doesn't support Avro files yet.
Yes.
And I had to fall back to PySpark. So.
Oh no. Okay, this is a fair point. I have personally looked at Avro files at some point. And I was a bit shocked from what I saw there. But that shouldn't dissuade us from providing support if it's relevant. So in general, we try to add support for things that we get a lot of sort of demand for. And I think so far Avro has not come up that often. But if it's something that's important to you, then please get in touch and we can talk about it more. In general, we try to follow a bit what people want in terms of what file formats to support, things like that. It's just that I don't think we have gotten a ton of requests yet. So that's, I think, yeah, but indeed Avro isn't supported at the moment. Yeah, thank you. Other questions up here?
Yeah, thanks for the presentation. What do you think are, say, the constraints given some system of DuckDB? Like, is there a constraint or is the constraint the system? Let's put it that way.
I mean, there are some constraints. Like one of the constraints that DuckDB has is that you cannot access a DuckDB database from multiple processes if they want to all write at the same time, right? That's a current restriction. It works perfectly fine if you're within the same process and you have multiple threads. But it currently doesn't work with you if you have multiple processes. So if your application server, for example, relies on multiprocessing for something, and then you want to sort of rewrite to the same DuckDB database, that's going to be difficult. So that is definitely a restriction currently. Otherwise, you're restricted by the amount of CPU power that you have and the amount of RAM that you have, and the amount of disk space that you have, because we can use disk space in many cases when we run out of RAM. But that's, in general, I think what the restrictions would be. Yeah. Cool. There's a question over there. Gabo, you have to just stop me if we're out of time, right?
Yes, last question.
Last question, okay.
Great talk. So you mentioned running on WebAssembly.
Right.
One of the restrictions in WebAssembly is you can only have one thread. So that is a constraint that is work with. Yeah, it still works, but only on one thread, right? So you don't get the performance that you normally get. So is that a concern when you go to different platforms? Like, how do you handle these trade-offs?
Yeah, I'm not sure that the single thread is always true in WebAssembly. There's Carlo is here, so he's our WebAssembly guy. If you have specific questions about that, you should talk to him. But when we look at a new environment, we try to see what is possible, right? And in WebAssembly, you're just restricted by what browsers allow you to do because, for security concerns, they don't allow you to do a ton of things. But I will say one thing. Chrome has actually changed their API for us already so that we can use original private file system in blocking mode to offload of temporary files. So there is change possible in that space, but it just takes a while. So I think that will be eventually resolved. We're just not entirely there yet. All right. Cool. Thank you.